Far from an ideal situation in which just a few but agreed and expressive ontologies give support to the semantic web, the reality is that many different people contribute with a variety of ontologies to describe similar domains, which introduces a quite heterogeneous landscape. In particular, such ontologies might differ on different features, such as language, terminology, modeling techniques. Therefore, if we want to use different ontologies for the same application scenarios, we will need to reconcile them beforehand by discovering links among their entities. Let's consider the following example, taken from the bibliographic domain, to illustrate how different people have modeled the same domain in very different ways, resulting in ontologies that differ in structure, granularity, and expressivity. If we examine the ontology on the left and see how they have defined the class book as a subclass of reference and a superclass of other classes like collection or monograph, and compare also with the ontology on the right, which is a flat taxonomy, and book has merely described as a subclass of entry, we see the remarkable differences between both of them. If we would like to use both ontologies in the same application context, we would need something to decide whether both entities are the same or not. And to that end, we can use ontology matching techniques. And the same for the other entities in the ontologies. Let's see now a couple of possible application scenarios in which ontology matching techniques could be useful to solve a certain task. Firstly, let's imagine that we have two web pages about food semantically annotated with certain ontologies. Let's imagine that in the first page the term apple is annotated with Wikipedia, while the second web page has used another ontology to annotate the same term, apple, in the sense of a fruit. If we would like to exploit such semantic annotations, for instance, for a semantic agent to automatically collect receipts containing apple, we would need to discover whether both entities refer to the same thing. To do so, ontology matching techniques might be useful. Let's now imagine that we have an ontology that describes the catalog of products we have in our company. This having an ontology can be very useful to solve many management and informational needs in our company. However, if we would like to expose such a catalog on the web, it would be recommended to use another ontologies that have reached a high consensus degree and are extendedly used instead or in addition to our own ontology. That is the case of the ontology good relations, which is used for e-commerce. Further, good relations is well supported by many search engines vendors and would increase our product's visibility. So at this point we have two options: either to use good relations only and rebuild our catalog from scratch, which might be costly and have an impact on our current processes, or simply try to discover correspondences between both ontologies using ontology matching techniques in order to export our data as instances of the new ontology when exposed on the web. In such a way, the instances that represent products in our ontology can be represented as well using good relations, therefore increasing their visibility on the web and allowing a better interoperation with other systems. In the previous slides, we have motivated the problem of ontology matching, and we have reviewed some possible application scenarios. In the rest of this lesson, we will review some basic definitions that are useful to better describe and understand the topic of ontology matching. Let's start with the idea of ontology matching itself, which is the task of discovering correspondences between entities from different ontologies. Given two ontologies, correspondence between them is a set of values composed of the ID of such correspondence, the ID of the two entities belonging to the two ontologies that we are matching. It contains also the type of relationship. There is if it is an equivalence, disjointness, or any other class of relation, and the value that indicates the confidence degree of this correspondence. Alignment between two ontologies is a set of correspondences between them, typically coming with some additional metadata, such as the multiplicity of the alignment, the method that has been used to get the alignment, the date in which it was obtained. Let's see now an example of a real alignment expressed in the alignment format. The alignment format represents the metadata associated with the alignment and the information of the correspondences. For instance, here we are the piece of the representation in alignment format that contains both ontologies that we are aligning. These are the two entities that are matched and the type of relationship between them, in this case equivalence, along with the confidence degree of this relation. Not only in the alignment format, correspondences and alignments can be expressed, because they can also be expressed using OWL and REFS constructs, or using other ontologies via their domain-specific properties. Finally, let's take a quick look at the general scheme of an ontology matching process. Of course, there are many ontology matching systems around, and they follow different approaches, but most of them follow this pattern that consists of the two ontologies as input, and optionally a set of initial alignments already known, and then the resultant alignment is given as output, and a set of parameters and resources that might be useful, for instance, thresholds, or the use of external resources, lexicons, or other resources might be useful also in the process.